Hello and welcome. This is Mouse Gunner, and we're back with some more automation, the Car Company Tycoon game, continuing on with the campaign roleplay of the Edison Car Company in 1996. And in this video, we're going to be building engines for the Constellation, which is our large four-door sedan. So there's going to be two main engines, a V6 and a V8. I'm actually going to start with the V8, and the reason I'm going to start with the V8 is because I'm not actually sure if I want to build a new V6 from scratch or if I want to use the one that we already have for the Star and modify it for the Constellation. I think a lot of that is going to be determined on the performance we get out of the V8. So we're going to have ourselves a V8, and it's going to be made out of cast iron. At least that's the plan for now. And I'd like to get this thing around about 5 liters, but I'm thinking about making it a longer stroke engine, because more than likely this will be the same engine we end up using in the Asteroid, which is the pickup truck for the Edison Car Company. So we're probably going to have to end up going up to, let's say, 92 for now. Let's see where we get with stroke here. So maybe up to 92.5 for the bore, then continue going up until we get to 5 liters. So it's a little bit longer stroke, but not by much. I think I'm going to go with an overhead cam, and for now I'm going to go with 3 valves per cylinder. This is my at least initial idea for this engine, is 3 valves per cylinder, single overhead cam V8. We're going to keep it cast iron, although I could see argument for it being an aluminum, but considering the fact that this is probably going to be the same engine we use in the Asteroid, I think cast iron is better for this application. We're going to go with cast iron across the board, but there's a likely chance we'll be switching to forged parts, at least for the Constellation version. Compression I'm going to bring down so we don't have any knocking, obviously. Probably about to 8 for now. Going to be naturally aspirated. And we want multi-point EFI. We'll go with single for now. Now, this is one thing I didn't mess with on the V6 with the Star. We just made it a single throttle setup. That might be something that we switch around with the Constellation, though. But for now, we'll just keep it single throttle, standard intake. At this point, we could make an argument for better quality fuel. In my mind, either regular or super. I don't really see a point of jumping up to premium for an engine in the U.S. market. From my experience, it's either one or the other. I'm going to make it regular for now, but that's something we can play with later. We'll go down to 25 for the ignition timing. Now, I'm not going to say I'm an expert with luxury vehicles in the mid-90s in the U.S. market, but just from my experience, it's either one or the other. We'll go with short cast for now. Dual exhaust. 3-way cat. And we'll do 2 reverse flow mufflers because we want to quiet this engine down. All right, well, this thing is actually overperforming what I expected. I was looking for somewhere around in 200 to 250 horsepower range, and we clearly knocked it out of the park as far as that's concerned, because without any modifications at all, we already have 250 horsepower practically. And I'm sure there's a lot of tuning we need to do. For instance, the exhaust diameter may need adjusted. So right now it says it's good for 284. So if we bump that down, no good. We bump it up. It looks like it's good for us. So it looks like 2-inch pipes are good. That allows us up to 351 horsepower, which gives us a lot of leeway. We're now above 250 horsepower. So I guess we just work with the engine. It's probably going to do quite well for us. So looking at what we have, I see a couple color changes here with the parts, which I'm not too surprised about, especially seeing how we're going to have to adjust the RPM limit and figure out where that's going to lie. So our peak performance index is going to come in at 6,500. Now, our power tops out at 6,100 RPM. So clearly, this is a bit of an issue as far as our parts are concerned. I thought maybe we would have to switch over to forged parts. I'm not going to do it. I guess I'll do it now. Might as well. So our choices are forged or lightweight forged, in my opinion. And I think forged is probably the better call here. And then we want I-beam steel, as it's better than forged H-beam. There's no real benefit as far as RPM is concerned between cast and the forged H-beam, because it's more about torque. So as you can see with cast, doesn't deal with torque very well, but the forged H-beam does. I think it also is less weight. Yeah, so you're going to have less weight, so you're going to have a smoother running engine. Whether or not we want forged crank, I might as well, considering that we did forged for everything else. That's going to lower down the weight as well, which is going to also make it a smoother running engine. Smoothness is good for a comfort-oriented vehicle that we're trying to build here. Okay, so moving over to the compression, we have a ton of fuel octane to work with, even with regular fuel. So definitely I'm going to bring up the compression here. And I think that we could probably even bring that up to 9.5. Safe to say with that. So we're producing a ton of power. This is honestly overperforming from what I expected to get out of an engine of this displacement. So I'm not actually sure where to go with this. We could back off the cam profile and make it a lower revving engine. And maybe we could actually go back on the parts, but we're going to have to move that cam profile quite a bit to get to that point. I mean, it's going to make the engine run smoother, which is good in some regards as well. I'm kind of thinking that this might be the right call, backing off cam profile here to about here. Yeah, I like about this point. So we still have a lot of fuel octane to work with. And definitely we can move the ignition timing, which is going to move around where the power comes in quite a bit. And we're going to have to play with where the peak performance index is, because we've moved that around quite a bit. Let's keep moving the cam profile around here. I mean, not the cam profile, the ignition timing around here. Oh, we probably want to lean off the mixture. Of course, that's going to make us knock, so maybe not as much. There we go. We're not knocking there. I think I'm going to lower down the compression to 9. Then bring the fuel mixture down. I do want this to be a more economical engine. Alright, so we're looking at 238 horsepower. I might have overdone the fuel mixture. Yeah, you know what? We'll go up a little bit with the fuel mixture. I mean, this is a luxury. I say luxury, but a comfort-oriented larger sedan. I guess it's okay if we don't get the best fuel economy out of it. And honestly, this fuel economy is not bad. V8s, for some reason, always do pretty well in this game. So I guess I can bring back up the compression, although we can't do it too much. Maybe to 9.2. And then ignition timing for the rest. Get a little bit of a... Eventually we're going to come to the point where we start to knock. Looks like we're just under that. Now we're knocking. All right, so 248 horsepower at 5,500 RPM. We really lowered down where the power comes in. And the peak performance index is going to be, looks like about 6,200. So as a result of changing things around, we're going to make things a lot more reliable, which is good for if we were to slot this engine in the asteroid. Now, part of me is thinking, can we switch back to cast parts? And the answer is definitively no. So I think we'll keep the forged parts. Now, lightweight forged is better on RPM, worse on torque. That's not good. We don't want that. I think I already evaluated that. All right, so what else can we mess with? Well, we could make this a twin throttle setup, which doesn't appear to actually do much outside of just making the engine more expensive and giving us better throttle response. I really don't care about that in this engine. Honestly, I think I'm pretty happy with where we are at. As I said, my initial goal was 200 to 250. So we could have gotten a lot more power out of this engine really easily. But we ended up detuning it because, honestly, I think we were just producing too much power for what we're looking for. And I wanted to bring that down. And as a result, we could get a more reliable engine that's lower revving and decent fuel economy. I'm pretty happy with the engine. So we're going to call this the CB 5.0, and this is the 96 version. And we're just going to call this the CNA variant. As I said, I plan on making an asteroid variant of this engine. So let's go ahead and save that on up. Oh, there is one thing I'm forgetting, and that is VVT. We have had that on our other engines. I don't see a reason why we shouldn't put it on this engine. And we can see this does give us a benefit in both smoothness. It does drop off of reliability a little bit, but I think the gain we get in economy, performance, overall lowering of emissions and all that, as well as a little bit of a boost in power, all good for me. Pretty happy with that. Let's just double check that our exhaust diameter is where it needs to be, which it appears it is. All right, now let's save that up. And now that our V8 is performing a lot better than I expected it to, I'm still torn about what I'm going to do with the V6 that we're going to put in the Constellation. We might actually end up doing an experiment here. We could either build another engine, and then that makes it so that we'll potentially have 3 V6s for all of the models in our current lineup. Because we're going to have a different V6 for the Comet, because we want that to be very much a performance-oriented V6. So, if I were to build a new V6, it would be the V6 that would be used in the Constellation and the Asteroid, more than likely. Or, I could just have 2 V6s, and I use the one V6 that we already have, the SV3.0, for both the, well, not only the Star, but also the Constellation and the Asteroid. So let's do an experiment and revise this engine and see if we can get it to perform better enough that I think that it's a good option for the Constellation. So we're going to revise this engine, and we're going to clone the variant here and switch to that variant. And there are a couple things that I think we could change. First off, we could change it from a 2-valve per cylinder to a 3-valve per cylinder. Oh, no, wait, it doesn't let us do that. That's locked in. So never mind, we can't do that. That's actually a bummer because I believe in the modular V8s that Ford used, the Mustang V8s had 3 valves per cylinder, but all of their other V8s had 2 valves per cylinder. So that's kind of unfortunate that you can't do that with a variant, but I kind of see where that's coming from, though. All right, so one thing that we wanted to do was I want to change it to a dual exhaust. But obviously we're going to have to change profile here to be narrower. Looks like 1.5 inches is where we want it. Now, this is actually not, I think, giving us really any benefit over the single exhaust before. I think power is pretty much exactly where it was. We're also going to slap on another reverse flow muffler to suit the Constellation. We want a quieter, nicer ride. Now, to get more power out of this thing, I might go with a twin throttle setup, although from what we've experienced before, this actually doesn't affect power at all. And it doesn't make a whole lot of sense to switch to a more premium fuel. So yeah, the more I think about it, the more I think that this variant is just not going to work. So I'll delete this later, but I just don't think that I can tweak this engine enough. I mean, I could make it less fuel efficient. I could bump up the fuel mixture, which would make it perform better. But I could also do things by giving it, better pistons and conrods so they can take higher RPMs. I could make it a higher revving engine, and as a result, be able to push it a little bit harder than I think I have this engine set up to be pushed. But I really don't think it's right switching up to super or premium fuel if we didn't do that with the V8. That seems kind of counterintuitive. Now, we do have a bonus with throttle per cylinder in power, but I'm not liking that option. So I'm definitely thinking we have to build another V6. I don't think this engine is going to be well suited for the Constellation and Asteroid as I had intended. So we're going to build a new V6, and this is going to be more than likely a 3.6 liter V6. And I'm going to build it cast iron. I'm going to build it to have, again, a longer stroke. So I'm going to go up to maybe about 92.5, like what we had before. I wonder if we can get 3.6 with pretty much the same setup. Okay, so no. Probably want to bring that down to 90 or 91. We'll see with 91 where we end up. All right, that's probably more what we're looking for. So I want to get more on the nose here. Oop. There we go. Now, looks like it's going to be off by a little bit. That's all right. We don't need to have it be perfect. There we go. So, roughly 3.6 liters. We're going to go with an overhead cam. I think I'm going to make it 3 valves per cylinder. And moving along, we're going to go cast across the board to start. Compression will bring down. And cam profile will keep as it is. We'll probably add on VVT later. Naturally aspirated. Gonna go with ejection, multi-point. Oh, we didn't change the year. I hope I put the right year for the other engine. I think I did. Okay. Multi-point EFI. Single throttle, standard. We'll go with regular fuel. And we'll bring down the ignition timing just to prevent any knocking from occurring. We're going to go with short cast, dual exhaust. And 3-way cat, reverse flow, because again, this is the Constellation. And start. And I just realized I called that previous engine the CB 5.0. It should have been the CV. Oh well. So, definitely getting a lot more power out of this engine. Let's mess around with it, though. We're going to need to bring up the RPM limit here. Alright. I might do the same strategy I did with the other engine, bringing down the cam profile. But for now, fuel octane, pretty good. Let's bring down the fuel mixture to 14.5 for now. I'd like to get it down to 15, but we're going to have it for now. And then, clearly this engine has to produce more power than the previous engine. Bring this up to 9. Now, cam profile. What do we want to do with this? So we bring that down to there. Let's see what we can do with the engine at this point. So ignition time is probably going to mess around with that quite a bit, imagine. Continue to bring that around. Getting close to the limit before we start knocking. And the thing is, I'm not sure if I'm going to know if it's... Oh yeah, this goes if it knocks. Okay, there we go. So we definitely brought down where our power is coming in so that we can bring back until we get to our peak performance index, which looks like 6,200. So we're almost copying the performance of the V8 as far as how the power comes in perfectly. So now, probably going to want to switch up to forged parts as we did before. It's going to give us more fuel octane to work with as well. Might as well go with forged steel as well. Alright, so far so good. Do we then want to bring up the compression to match? Alright, so 9.2. Then do the rest with the ignition timing. And we did just jump up the where the power came in, but I don't think the peak performance index is probably going to be affected. Okay, and there's our knocking point. So we got it up to 182. Let's just check. Yeah, it does appear that that's still where our peak performance index is, so I'm not going to have any real effect on reliability. Reliability is very good. Let's now make the switch to VVT. So we got a couple horsepower out of that. Now, the other thing that we need to do is we need to check on our exhaust. So it looks like restricting them did us good. Let's continue to restrict. Okay, so 1.5 inches seems perfect for this engine. 185 horsepower, 208 foot-pounds of torque. Not bad. What else can we do with this engine? Not really sure there is much. I mean, this is not a bad performing engine, and I think it gives us the kind of performance that would work for us in the asteroid as well. I might even name this after the asteroid, because we named the other engine after the Constellation, just to avoid confusion. But we'll make this the variant that goes in the Constellation. So, all right, let's do that. We're going to call this the AB 3.6 96, and we're going to make the variant the CNA, so the variant for the Constellation. Save that on up. And let's take a look at our engines. Now, one thing I could have done, thinking about it, is I could bring the fuel mixture down. But it looks like our economy really isn't bad. So let's take a look at things and then make that call. So currently, I'm going to have to delete this variant. So ignore, I'm not this variant, the engine variant 1. Just ignore that one. That one we'll just pretend doesn't exist. So currently, the two engines that we've built are these two. And then we also have a couple more engines besides. So, looking at the performance of the two engines that we've just made. as far as comparing it to the Stars V6, which we contemplated putting in, we got 185 horsepower versus 168. Decent improvement, almost an improvement of 20 horsepower. Pretty happy with that. Torque-wise, we got 40 foot-pounds of torque better than the V6 and the Star, which is going to make it, again, a good candidate for the Asteroid. Nice torque for pulling heavy loads. Responsiveness, it's more responsive. It's the most responsive engine out of both of these. I mean, honestly, a lot of the statistics between these two engines, we built them very closely together. Same responsiveness, the same kind of overall power dynamic. I'm pretty happy with that. As far as, what is this? This is smoothness. We got a little bit better smoothness out of the V6, not by a whole lot, but the V8 is very smooth. Good, and it's great. Loudness is going to be quieter engines because of the two reverse flow mufflers that are quieting it down. Reliability, these are the two most reliable engines we've built so far, coming in with 66. It's not a big departure from the low point of the 62 that we have, and most of the other engines getting 64. Not too much of a divergence from that, but still the most reliable engines that we have. Weight-wise, though, these are going to be the heaviest engines we have because they're the biggest engines we have. Fuel efficiency-wise, though, again, good performers. 20% for both engines, which is better than all of the other engines we have. Of course, you have to take the weight into account to what kind of a fuel economy the vehicles that have these engines are going to get, but not bad there. We did use the regular fuel, so that's what that's representing. Emissions comes in at 417 for both engines. Again, remarkably similar, which is, again, worse than all of the other engines, but these are bigger engines. So I kind of see that. Production units, again, these take more time to build than the other engines we've built so far. Again, being bigger engines, that makes sense. And also the 3 valves per cylinder. Both of these engines have that. I don't believe any of the other engines did that we built so far. And cost, again, these are more expensive. We're also using forged parts rather than cast parts, which we've used in our previous engines. So there you have it. I'm pretty pleased with these two engines, and I hope you guys have enjoyed this video. This is Mouse Gunner, signing out.